Alright, now we're going to look at examples of finding inverses where our original functions were one-to-one, but we're going to limit the domain in order to force them to be one-to-one. And there's usually two ways to go. Either you pick where it's increasing or it's decreasing. My rule of thumb is I'm going to pick where it's increasing, as that's typically how we go, although technically you could go the other way. But again, increasing is sort of the rule of thumb for these. Alright, so this is a parabola that opens up. So it's not originally one-to-one. But I'm going to pick the limit its domain. So first of all, I'm going to graph it as it is. So it's the parabola x squared function that's been shifted to the left 1. So it's been shifted over here. It's a -1, 0, and then stretched by 5. So that gives me the point when I plug in 0, I get 5 out, 0, 5. Alright, then it's a parabola that is opening up, and I'm going to draw it as is to start off with. I'm going to draw it with a little more curve than what I have. I'm just making it worse. Enough. So that's the point, 0, 5, there's f of x. But I'm going to limit it to this side here where it's increasing. Alright, so this is the side I'm going to want. This is the side where it's increasing. I'm going to try to draw this again because I did a horrible job, so give me a second while I draw it again. One, two, three, four, five. Not sure if I did much better there. So I'm going to limit it to where f of x is increasing. Well, it's increasing from -1. I'm going to include where the vertex -1 to infinity. And so that's what I'm going to limit its domain to. Which means I want f of x where x is greater than or equal to -1. And so I don't want this other side, so I'm actually going to erase this other side. I don't want it. The only piece of the function I want is the piece from -1 to infinity. Then my function's 1-to-1. If I try to draw a horizontal line, it will only hit it once, and now it's 1-to-1. So I forced it to be 1-to-1. And so its range, in this case, and this is sort of important to know. It's going to come into play when we go solve the inverse. Alright, so its range, if you'll see, its range goes from 0 to infinity, right, in the y direction. And so there's the function I want to find the inverse of. Alright, so now find its inverse. I'm going to do my work over here. So the first thing is set y equal to the 5 times x plus 1 squared. Flip my x and my y values. Divide by 5 first. Right, isolate the square terms to the order of operations. Divide by 5. And so I get x divided by 5 equals y plus 1 squared. So at this step, I would take my square root. Remember, when we take our square root, we're technically supposed to do the plus or minus. That's why I said this kind of plays an important role. Remember, what was the range in my original function is going to become the domain, the x values, in my inverse. And so that means I only want positive numbers, positive x values. So that means this is going to come out positive. And so I only picked the positive version of it. Had I gone the other direction, it would have been going off to negative infinity, -1 to negative infinity, and it would have still kind of followed along the same thing. So we would have picked the positive, or the negative version in that case. And so there's the positive square root, because that's what I want. So positive square root of x divided by 5 equals y plus 1. So I got rid of the squared. Now move the 1 over. Square root of x divided by 5 minus 1 equals y. And there's my inverse. F prime of x equals square root of x divided by 5 minus 1. And so I'm going to draw it in red. And so its domain is 0 to infinity. I have to have positive values in for x, because I can't plug in negative values, right? Because the x minus 5, I can't do that. Its range should come out negative 1 to infinity, and when I go to graph it, it will. And so I'm going to use the same points that I had up here. So I had the point here, which I erased, which was negative 1, 0. So remember, x and y's flip, and so I want to see when I plug 0 in, I should get negative 1 out. So f inverse of negative 1, inverse of 0 should give me out negative 1. So when I plug 0 in, well, that zeroes out, and it does give me the point negative, I keep saying it backwards, gives me f inverse of 0 equals negative 1, which is the point 0, negative 1. I'll go to graph it, and so 0, negative 1 puts me here, so 0, negative 1, which is, again, flip my x and y, so that should be the case. Oh, I think I'm going to draw that in red. 0, negative 1. And the next point should be 5, 0. So I'm going to plug 5 in and see if I get out 5, 0. So f inverse of 5. So I get square root of 5 over 5 minus 1. Well, square root of 5 over 5 is 1. Minus 1 does give me out 0. So I do get 5, 0 as my point. So I'm going to graph 5, 0. So there's 5, 0, connect the dots, and there's my inverse. Its domain is 0 to infinity, right? 0 here to infinity. Its range is negative 1 to infinity, and so it does have the opposite. Every point on my inverse is a flip of the point on my original. All right, so again, this red piece here is perfectly reflected of the blue piece over that line y equals x, remember that line that goes through the origin. And there's the inverse of a function where I've limited its domain. So I'm going to do a second example. It's very similar to this. The function's just a little messier. It's this is a fractional power, so it's 2x plus 3 raised to the 2/3. So this would be the, if we're writing that out, that would be the cube root of x plus 3 squared, just so that you're aware of that's what that is. It is not 1-to-1. If you graph it, it's one of those V shapes. So I just suggest using your calculator. And you'll see on the calculator that it does have sort of a vertex-like shape. At negative 3, 0, it has sort of this V. Alright, there's the graph of f of x. So I don't want it all because it's not 1-to-1, and so again, I'm going to do the same thing. I'm going to pick where f of x is increasing. It's sort of a rule of thumb. Well, increases from negative 3 to infinity, and so that's what I'm going to limit the domain to negative 3 to infinity. So I want all my x values to be greater than or equal to negative 3, right, which means I don't want this side, so I'm going to erase it. All right, that's the only piece that I want, and if you look at it now that I've limited it, that it is now 1-to-1. Now it's 1-to-1, which means I can find an inverse. Its range is 0 to infinity, which again, this is going to play an important role when I go to find my inverse. All right, now solving for my inverse. So first thing I'm going to do is I'm going to use the original. Y equals 2 times x plus 3 to the 2/3. So first thing, get rid of this is first thing, flip your x and y. So x equals 2 times y plus 3 raised to the 2/3. So first thing, divide by 2. And this is going to be very similar to what we did. The only thing that is a little more complex is the fractional power. So if I remember how we deal with this, though, we raise it to the reciprocal. So we'll raise it to the 2/3 raised to the 3/2. And when I do to one side, I do the other. Since it's the half, this half represents the square root, we would technically do plus or minus again. But remember, my x values are going to be positive because the range is 0 to infinity. And so we only want the positive because I already know my x values should be positive. And so we only pick the positive of that. So x divided by 2 positive, raised to the 3/2, those cancel each other out. leaves me with y plus 3. Last step, subtract 3. So I get x divided by 2 raised to the 3 halves minus 3 equals y, and so there is my inverse. F inverse of x equals x divided by 2 raised to the 3 halves minus 3. I already know that its domain should be 0 to infinity. Its range should be negative 3 to infinity, and we'll check it out graphically. And I'm going to use the same points to graph above, so it shows that my points flip. Alright, so the point, I only have 1 point. I need a second point in order to... the problem with this one is my second point probably won't be really neat. So let me see if I can find a nice second point. Alright, maybe I'll just start with the first point anyway. So I'm going to start with the first point. Negative 3, 0, so what I'm going to do is plug in 0, I should get out negative 3. And I do. When I plug 0 in, that's 0. And so I am left with negative 3. So inverse of 0, so I do get the point 0, negative 3. So I'm going to go graph that. 0, negative 3 puts me down here. Alright, now a second point. Let me see if I can find a nice one on my table. Looks like 5, 8 will give me a nice one. So I'm going to use 5, 8. So if I plug 5 in, 1, 2, 3, 4, 5, should give me out the point 5, 8, if you plug in 5. And so I'm going to see if the flip of that's true. If I get 8, 5 out. So I take my inverse, plug 8 in, so I get 8 divided by 2 raised to the 3 halves minus 2. So 8 divided by 2 is 4 raised to the 3 halves. Is 8 minus 3, which does give me out 5, so it does give me out the point 8, 5. Alright, which is what I wanted. 8, 5. 1, 2, 3, 4, 5, 8, 5. 8, 5. Alright, and so remember, it's got the opposite shape here, so it should curve out and up, and eventually they will eventually cross. Alright, at some point they will cross. They'll cross on that, y equal x line. But there's the shape of the graph. The domain is 0 to infinity. The range is negative 3 to infinity. Each point on my line is flipped. The x and y values are flipped. And I checked that with 2 points. Right? It did flip when I went to graph it. And so that is my correct inverse. Alright, so we'll stop there. So that was practicing inverses with limited domains. Alright, so that finishes up this section of notes, and so we'll get into exponentials and logarithms in the next few sections, which, again, it's important to understand inverses to understand what a logarithm is. It really is. A logarithm, students tend to have trouble with logarithms because they don't understand the logarithm is the inverse of the exponential. Alright, and that's what we're going to get to in the next few sections.